Alrighty, let's lower down the volume and yeah, get started. Today we are going to do something I don't even know what, because I have so many ideas and I'm kind of like I'm trying to make it a prototype, but at the same time it's complicated. So while I was not streaming, I had completely redesigned the implementation of the position system. I don't remember exactly the implementation we had on stream, and I don't even care what it was. The new implementation is looking like this. We still have the make movable. I'm not sure if that was a function I introduced on stream. What that does, if I go to definition, is just imposes some stuff onto our components, so acceleration, velocity, and position. And these should be uh, with the values of 0, 0, at least I hope they are. And once we're done with the make movement, we know that all of these components are here. What we are going to do next is we're testing if we place some acceleration onto this object. Does the acceleration propagate its way down to changing the velocity and the position? And in this case, we consider the delta to be equal to 1. So that's going to be very important for simulating movement that is um, beyond, like say, each second we want to move like some amount of space, but we need to simulate the frames in between each second. So how many every frames will have, divide 1 by that value, so like 1 over 60 or 1 over 30. We're going to get our time delta, and this is what we're going to plug into our equation. So we'll get all of this stuff here. So this is how it works. You see if we have acceleration of 1 and the uh, delta is 1. So the acceleration is basically 1 unit, 1 grid unit probably, over, sorry, 1 grid unit in a second. If 1 second passes, or like one something, it doesn't matter what it is, some kind of time unit passes, then the velocity should become 1 throughout this time, and the position should have moved by 1 as well. And then if we, increment it different ways, it should yield the same result. And if we look at the definition of movement system, you'll see it's actually quite simple. Um, and so this thing here is first querying all of the acceleration and velocity. After it's done with that, it's going to increment, basically for every component that has these two, it will add the acceleration times some delta multiplier, and then it will add this to the velocity, and then the same will happen for velocity and position. And so the test will verify that it is true, and I am pretty sure this one will fail to compile, because just before stream I was trying to implement the collision system, and I realized that collision system is not something I am ready to implement at this particular stage. The reason for that is because what on earth? What's it saying? What is your issue? No sources given to target. Sand system. Uh, oh, I know. It's inside of this one. Actually, not this one. Where's my SRC? It's probably here. It's this one that's getting in the way. Oh, what are you doing? Okay, let's use this. Let me real quick fix my thing. There you go. So two tests passing. The first one is the make movable. The second is the movement system. So that is the test. And actually, writing tests, I know some people are saying like, "Oh, tests are just a waste of your time," but this has been just such a helper for me because like, first of all, I see what it would look like, and that's probably the main issue I'm struggling with. Like when I'm writing code, I'm like, okay, what do I name this class? Like what should be the return type? What's the architecture? When you write the test first, I usually start with arrange, act, and then assert. And so you first of all understand, okay, what are the prerequisites for some action. So you kind of like understand that you don't want to do a lot of setup. You just want like a little bit of it, right? That helps also with the separation of concerns. You don't want in your arrange act initialize the entirety of your game. You just want to initialize the smallest possible thing. And this also gives you a list of all the dependencies for a particular system. So all of the components need to be assigned to an entity for it to work, otherwise it would not. And of course, there might be a few here that are not necessary. That's not okay, that should not be there, but you know, it's okay. Um, what's important is that all the dependencies will be here. Maybe some extra ones, but that's not really that terrible. And then here is the actual movement. This is the what is the actual act. How does the system behave? What kind of parameters do you need to pass in? And in this case, you see I'm just passing in the C registry and the time delta. This is all that's required for it, which by the way is a really interesting thing here because you don't actually pass in any entities into this movement system. You don't do that. You just pass in the registry, which has all the entities in your game, and it just ticks all of them at once. Or better say, it's not at once, it's more like, you know, um, more like an increment, like it ticks every single one. And also I realized just now that the movement system is quite tightly, um, it's actually quite tightly tied in with the collision system. Yeah, ooh, not very good. That's why I'm not willing to talk about collision just yet. Um, and then here we have the actual assert phase. And what I started to implement in this assert phase is I started making it so that each of these assertions would have a little comment next to it, so that later, if you just look at this code and you're like, what the hell is happening? You actually get an explanation right here. So that's just something I thought would be pretty good, pretty good. And also when the error occurs, so let's say I modify this value right here in such a way that it would make the test fail. Okay, it's lag while it's running this test. It's not very good. Also just realized you probably don't hear any music. Should probably increment that a little bit. Let me see. Okay, that's a little better. So if you look here, it tells you the expected quality of these values. So coordinate, acceleration, and it tells you should not change acceleration. So I think that's pretty good. You can use these for you can use these comments, not really comments. You can use these things for displaying something that is not tested within this assertion. For example, why is it stuck on that compilation right there? Not sure. For example, one thing that you can do is you can provide um, some like intermediate computation in this um, text here. But I'm not doing this here because, well, I mean, all of it is right here in this assertion. And if you have some intermediate computation that you are willing to track and display in case of an error, you might as well assert or expect that before here. By the way, if you're using Google Test, and this is Google Test, there are two types of assertions. The first one is the expect assertion. The other is assert, and these would be the same thing. So yeah, I could write expect equals or assert equals. And if you're comparing, say, like assert less than or greater than, there's also an expect statement for that. The difference between the two is that the assertion will not continue the test, so it would just terminate immediately if it fails. The expect clause would instead, so it will make the assertion. If it fails, it will display the error, but it will continue on testing. And that is going to be uh, a better way of, like, it will allow you to better understand what the issue is. I think I'm going to change these to expect right now. The reason being, oh, sorry. They're all caps, by the way. Expect like this. The reason being, oh my goodness. Is my autocomplete this CPU heavy or what is happening? Also, okay. Yeah. Interesting. That's not supposed to happen actually. Weird. No, I don't like this. Oh, please don't tell me it's too laggy for streaming. Also, while this stuff, okay, it compiled. I'm gonna show it anyway. Um, there is this here, set cmake export compile commands on. What this allows you to do is within Emacs, you have the LSP, which I forgot what it stands for. Let me Google that. Emacs LSP, I think it's like language server protocol. There it is, language server protocol. And what's nice about the LSP is it provides you all of this autocomplete functionality. It also provides you this formatting functionality. It can also uh, automatically add include statements, and it can tell the text editor, hey, put this include statement on this line. So that's pretty powerful. Um, but in order for the LSP to work properly, you need CMake to export all of its settings to a special file. Forgot what the name of it is. In fact, I don't even see it here. I think it's in .cache clangd. Yeah, I'm not sure. It's not here. Maybe it puts it in like a separate folder or like a. Yeah, I don't even know where that is. It's just somewhere. Well, anyway, we don't have to worry about that. What I am interested in is let's probably commit these changes right now. So space colon maggot. So I'm not sure why we don't have a prompt. I'm gonna quickly. So untracked files, I'm not gonna track these just yet, but modified here. Also, is this still in component? Let's delete this component right here. Don't want any of this. Okay, let's see here. So include, yes, let's stage this, this, and that. Commit, and let's Also, what's really nice about Emacs is I actually can see the diff right here. This is using Maggot, of course. So like I can see what I did. So I added the T entity here, remove the public SDL, and this is the main commit here. So modified movement system test to have expect insertion what's this red? Oh, it's like too long, right? To use expect. Okay, there we go. Commit that. So then we can quit Maggot. It's pretty useful. I mean, like this is pretty much VS Code, but it's got all of the nice editing features of Emacs. Maybe it's a little laggy, but I'm not sure. Um, Maybe VS Code is a little more optimized in this way, but come on, like Emacs has so many. Like Emacs is just right now, at least for me, so much more extensible and just has so many more features than VS Code. It doesn't really make sense for me to use VS Code. I did use VS Code, but like it's just not. No, no. It's like just just so dumb for me, at least. Of course. Okay, so one of the things that I wanted to do today is make the rendering system, because I'm pretty sure even if the position system changes, it's not going to affect the rendering system quite as much as I originally thought. And I actually talked to some people on the Ent Discord, and after I posted this message saying that, like my movement system is tightly coupled with the, or better say, my rendering system is tightly coupled with movement system, so that's a bad thing. They pointed out something that I realized a little bit later is that it is supposed to be this way. Like, what do you expect? Do you expect to have like a completely uh, dependless thing? Like every system is not dependent on each other? That's kind of impossible because you don't compute stuff just for the sake of computing it. The rendering system would be probably the most vulnerable one because even if, say, something like a position system, it may not be closely related with some other system in the game, the rendering system will need to know the position of an entity. And it would also need to know the state of the entity. And it would have to know the health of the player to display like some title, not title bar, like a health bar. It's gonna have to know so many things. Um, but because we're writing a prototype, rewriting stuff is not as expensive. And in fact, the more we rewrite, okay, actually, rewriting more is not very good, but having this ability to freely rewrite and not have the burden of the entire game on us, it's pretty good. So this is just a prototype right now. We don't really like have to be perfect. In fact, the more mistakes we do, the better. So let's do something uh, pretty simple. Today we're gonna write a rendering system, and for this I had already prepared our assets folder right here. And this one will have a few things in it. First one is this PNG, which I'm gonna zoom in a little. So this has a bunch of sprites, and it does have a license. And I think it had a README, which I deleted. Does this have like um yeah, I think, you know what, let me grab a README. Uh, I need to include the README. Actually, instead of including the README, for now at least, nah, actually, I think I do. Let's see here. Does this have something I can quickly grab? Anyway, so this here is where I got it from, and I think I'm just gonna copy this link. It's just gonna be the easiest one for me. Um, that's just like it's gonna be the easiest thing I can do right now. Yeah, that'll be it. So if we go back here, basically, this is the Taoshi that I'm downloading. And unfortunately, I cannot zoom in. Kind of unfortunate, but this is what it looks like. Actually, on the black background, it looks pretty good. Yeah, yeah, that's gonna be pretty nice. Very nice. And so these are on a transparent background, which means that if I really wanted to, I could put them on any background I want. And I tried making some modifications to um, like I tried making my own tile set, but I realized very quickly it's just not gonna work. So this is gonna be pretty good. In fact, we might even use this specific tile sheet for the actual game we're gonna write later, because this is something you can use, as far as I understand, for commercial use as well. This here is the license, so it tells you you can copy and redistribute the material in any medium or format, remix, transform, or build upon the material for any purpose, even commercially. The game is going to be probably free, so I don't really care about it much. And these are the terms. So you must give appropriate credit, which I actually want to know what that means. So if supplied, you must provide the name of the creator and attribution parties, a copyright notice, a license notice, a disclaimer notice, and a link to the material. CC license priority version. The title of the material if supplied and may have other slight differences. Okay, so the name of the creator. I mean, is this enough? And contribution and attribution parties. I am not sure they did not like specify that. Actually, that might. Yeah, that is in the README. Dang. Do I really have to download the zip again? Please no. Is there any way to get the README from this thing here? No. Because for me, it's like you have to download it, you have to extract it, you have all of that. Like, yeah, jeez. Okay, you know what? I'm gonna keep it this way. The license is there, the link to it is there. It's in my computer. People are watching the stream, they can just go here and like the link is here. Um, there it is. Not that long, so you can type it out. So that's the where the credit goes to. Okay. Let me actually put my browser over here on the screen you don't see. So that is that. I'm gonna probably leave it to that. So with that, we have the actual PNG, and I'm gonna grab this particular character right here, and I'm not going to grab every single one of these states here. I'm just gonna grab this particular one. Quite like it actually, and we're gonna go with the enemies, probably with this one. Uh, we're not gonna implement the animation system just yet. So if these are 16 by 16, that's gonna be 1, 2, 3, 4, 5, 6. So this is 5, 6, 7, 8, 9, 10. 11. Okay, 6, no, 5 and 11. Okay, we'll see about that. Okay, so now that this is done, the movement system is done, let's do the rendering. And because we're doing rendering, uh, the rendering system cannot be tested um, using a test suite, unfortunately. It has to be tested visually, but we can make it testable at some level. Uh, like say by like let's say there's some variable that the rendering system will assign to this like particular um, component. So a particular so if there's some component that is attached to the entity by the rendering system, we can assert that it has some properties. I'm not gonna write tests that assert that something is on the screen because that's just no, 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 no. I'm not. But there we will be asserting quite a few things about the functions that are engaged in the movement system, or say the rendering system. So we need to write some of this code. So I would start in, can't really start in test, or can we? Actually, we can, but we're not going to. So in that case, in that case, let's do let's do it this way. Let's inside of here under system, create file called rendering.cpp. There it is. And we're gonna say that this rendering um, so here's something interesting about the rendering system. The way I want to render things, I'm not quite sure just yet, but I want it to be this field that's gonna, like, imagine this entire screen. Actually, it doesn't matter. So there's this field. The character can move forward, backward, left, and right, maybe on a diagonal, although I'm not sure about that. Um, yeah, maybe not on a diagonal. I don't want to move on diagonal. That would be an interesting idea, but like, yeah, honestly. Thing is, diagonal movement requires me making my own sprites for it, and it's just such a weird angle to work with. And diagonals don't really work with, with 2D pixel art stuff. I think I'm gonna leave it out for now. So, should we make a like a controlling system first? Although it's all coupled with SDL. So we're gonna do both. We're gonna do both. We're gonna do the rendering system as well as the um, something else. So let's just Google SDL. Okay, so simple direct media layer. I believe it handles controls, so that's pretty good. Dark theme. Oh, nice. Nice. Okay. Does it use Dark Creator? No. Okay. It's pretty good that they have Dark theme. Although I will admit it would be better if it detected the system theme and used that, because I'm not even sure. Let me see here. Um, is this thing? Aha, there it is. Oh, so the way they implement it, it's not even tied. Um, so they like send an entire different CSS for it. Terrible. This is not the way you're supposed to implement dark theme. You're supposed to leave it to the browser to decide, and you're supposed to be able to just click one of these buttons and it should apply the appropriate theme. But yeah, they did it this way, which is kind of weird. It's actually pretty easy to write this CSS for applying this automatically. I don't know why they didn't do it. Maybe they did it before. Nah, I don't know. It's just don't do it this way, please. I do appreciate the effort though. So here, let's see, do blah blah blah. I believe this is the one that we want. Introduction, source code installations, tutorials. Pretty sure we need tutorials. Um, I mean, yes, but no. Um, hmm. I need a thing where this is new wiki software and old wiki content. It's a work in progress. Here's the explanation. Be gentle, report bugs. Just edit it. Blah blah blah. Okay. Um. So I am interested in like a thing where they tell you, so here's a function, here's what it can do, here's how to use it, and like all of that. But I do not see any of this stuff right here. So how in the world do you use this thing? Uh, you know what? Let's just Google SDL. I believe the first one is create window. And this should give us something pretty good to work with. I'm afraid we might need to close SoundCloud for this stream because the internet is struggling. Yeah, you know what? Close. Yeah, that'll be better, hopefully. And in fact, might as well close YouTube as well. Okay, there we go. That should be better. Actually, now that I think about it, it's probably YouTube that's the most aggressive on resources. Let me bring back SoundCloud then. Let me just make sure that we are playing the correct thing. Okay, well that's from the beginning. Don't want beginning. Okay, let's just click this. No, not this song, please. Okay, oh, we've heard this song. It's all of them are awful. Oh my god. These songs are awful. I don't know why it's terrible, but just they're terrible. Something about them is just so bad. You know what? No music today. I'm just not in the mood for listening to NCS. Okay. Um, all right. It's pretty good. Okay, so this is the actual documentation SDL create window, and it is a C library. So, you know, this is namespaces in C, pretty much, just adding something, a prefix to a function name. But um, that's gonna be fine. The only thing we need to do is we have to modify our probably CMake lists. Let's modify this one. So add library. Actually, not add library. This one should not be modified. The one that should be modified is in here. And when we link, oh, we are linking SDL to here. Okay, that's pretty good. So then, in that case, I believe if we go to rendering.cpp, which is right over here, this is the file, we can then start looking at some of the things. So when we, how would we structure this? What's the best way? I think in the main.cpp, um, we have to actually like create window and all that. And in fact, we're gonna do it this way. So we are gonna say that we have SDL underscore window pointer, and something I'm not very happy about is the fact that it doesn't know that we're using SDL, which is fine, I guess. I mean, we can specify include ourselves, and I believe it is SDL to, what are the options there? Tell me. I guess SDL.h. Would that fix it? Okay. Not very efficient though, because SDL.h will include the entirety of SDL, but we might only need the window. So let's see if there is something to do with Windows, and there isn't. Um, I'm going to go AFK for like a little bit. I'll be back in about a minute. Okay, and I am back. It's pretty good. And cannot see any window thing. So let me actually go back to the browser here. It will tell you probably how to actually include, and it tells you just include SDL.h. So I guess that is the way. So I'm just gonna autocomplete to that. And there we go, SDL window. And it does tell you SDL.h, that's all you need. Um, I mean, I guess. Can you do that? Can you just like do this? No. Okay, so you do need SDL2 slash SDL.h. Okay, that's pretty good. So now we know what to include, and we are going to need to do something here. Let's include stdio.h. We don't really need that stuff. Is that a C example or a C++ example? I'm not sure. Um, yeah, it looks like a C example, but that's fine. So we need SDL window. So let's say we have our window. I wonder if you can create multiple windows. SDL init. Okay, and then you'll need to create your window, which I'm just gonna do Control C, paste that in, and here you just see we got a window equals SDL create window. So we are gonna get rid of all these comments, of course. But here's what we'll do. We'll say that this is our sand game. In fact, because it's a string, we don't really need to do it this way. And we can even do it like that. So initial X position, width, height in pixels, and then SDL. Okay, so how do I get rid of all of these comments? Would be nice if there was like a command in Emacs that would just strip away all of the comments from pasted code. That would be pretty cool. Okay, let's save this. Oh, wait, I pasted in. Let's do a save right here. You can see it completely redid the entire include, but that's fine. Doesn't have to be perfect. Like this. We can probably tell Clang not to like have this kind of structure, but we're not going to because there is just no real reason. Um, and we're gonna say here, check that the window has been successfully created. So basically, we have to check if um, window. I want to know. So it's basically equals null. In that case, we're gonna do C error SDL window could not or cannot be created. Cannot be created. And I guess this is where we return. In this case, I'm not going to return. I'm just going to do an exit. Um, exit one. Okay. Oh, we actually get this get error. Could not be created because so how do you So it's SDL underscore get error. Okay. So hopefully we'll never have to use this particular one. Um, and actually, you can see it does include a few things here, which is rather nice. It does not know how to include C error. Um, the reason for that is, well, actually, I'm not sure why it's, oh, because in order for you to know, you need to write std colon colon C error. Okay, now we'll include IOStream. And so I kind of want to know if I just like um, compile this right now. It should work. Yep. It did not run any tests because, well, the test target has not been rebuilt, but we can run command dot slash build slash main. And ta-da, that's all we get. Nothing, just kind of weird. I mean, yeah, there it is. That's main right there. But it did not do anything. I believe it didn't have the time. So let's use SDL delay. So after we have done all of this, we're going to delay for 3000 seconds. Then we're going to destroy and quit. Of course, we are going to, let's see. Oh, wait, hang on. Pasted too much. P compile. Oh, sorry, compile is this. And then run this command. Okay, there you go. We got a window. Of course, this window does not have any graphics inside of it, but that's not really the issue for us. We'll put graphics inside of it later. Okay, that was the window. It actually is much easier than I thought. Um, and it is a floating window, which I didn't really think that it would be a floating window. I thought it would not be a floating window, but that's pretty good. So that means that SDL kind of knowledgeable about uh, what it should be. Okay, um, now here is what I am going to do. I'm going to open my Alacrity config. Um, so that would be inside of .config alacrity.yaml, and oh, sorry, not Alacrity. That would be i3 config. There we go. And where should we put it? It seems like workspace 3 is usually unoccupied by anything, so let's put it. Actually, we can put it on workspace 2. That's kind of the purpose of it. So we need to find a section here about for window, and let's put this right here for underscore window title equals sand game. Um, and actually, I think I put it in the wrong place because this is not where I assign windows to the workspaces. Maybe I am. I'm not sure. Let me see here. there it is. Where's my assign? There we go. And we're gonna click here, assign. Um, dollar workspace 3. Okay, save it, reload the this config, quit Emacs. So now if I run this command, it should put it on workspace 3. There we go. So it goes here, and I would like to actually make it be full screen. So let's do that. Let's make it window. Oh, nice. You can put waterlet. Oh, so this is actually really good for us. So I believe the way that we do all of this is SDL window open GL, uh, but then uh, we just do a pipe here, borderless pipe, maximized, not full screen, just maximized. And if we compile this and run, should see a window. I mean, we don't really see it. Should be there. Um, let's increase this delay here to say, why can't I? Yeah, okay, so this should be, oh wait, I did not recompile. Let's compile that. It's gonna be a lot of me learning how to use SDL, but that's totally fine. That's kind of what the purpose of this is. So you can see that there should be a window there. And I should be able to like resize it. No? Okay. You know what? Let's let's make it um actually like have something in it, like a black square, for example. Uh, in this way, we're gonna see that something is actually there. Um, so let me take a look here. Once we create this window, and so with this is the thing that we did. Okay, pretty good. Um, you can specify width and height and position. So we're not really gonna, yeah, we're not gonna do that. Um, Instead, let's learn how to draw. And so how do you like, oh, you just like query, oh my goodness me. Do you have like do they have like an index of like all the stuff that's in this SDL library? Like all of it. Just, oh, there it is. API reference by name or by category. Actually, we don't want by name. We want by category. Okay, I found it. This is the thing. I hope. Yes, I found it. Something you'll notice is that it actually tells you in which header file it's defined. So that is really good. Display and window management. Okay, pretty cool. Oh, you can disable screensaver? What does that do? Prevent the screen from being blanked by a screensaver. If you disable the screensaver, it'll automatically when SDL quits. Oh, pretty cool. Whoa, that's nice. Flash window. What's that do? Now, request a window to demand attention from the user. Oh, I guess it's like um, it's like you know how like you get a notification, um, like if I run this, see how this is like red here? This is like, I guess this is what it will do, like request your attention. So why can't I quit this? Cannot kill this window. I mean, if I use X skill, I probably can. Yeah, maybe. Okay, so this window that's not initialized properly, it's kind of scary for me because I don't know what it is. But that's a lot of stuff. We're not gonna go into detail on every single one. So let's go to rendering. I guess this is where we should be. Filled rectangles. Yeah, I want to fill the entirety of the screen with this rectangle of black. So how do I do that? API supports the following features. All these may be drawn in opaque, blended, or additive modes. Texture images can have an additional color, tint, or alpha modulation applied to them, or may also be stretched with linear interpolation, rotated, or flipped or mirrored. Okay. For advanced functionality like particle effects or actual 3D, you should use SDL's OpenGL Direct 3D support or one of the many available 3D engines. I'm not going to go the 3D route just yet, but it is good that it does support 3D. This API is not designed to be used for multiple threads. CSDL issued this for details, so we're not going to go there. I guess we just need to create a render. Uh, so you supply the window, index, and this. The index of the rendering driver to initialize, -1 to initialize the first supporting the requested flags. Ooh, okay, I don't know what this is. Returns a valid rendering context or null. If there was an error, call SD get error for more. Like that they have examples, it's pretty good. So we have window, render, bitmap, texture, surface, position, loop should stop, SDL false. What is this? You can't use a bull? Oh my god. SDL bull. What? Oh, it's funny. It's very funny. It's very funny. Okay, let's keep on reading this. So SDL init. Also, I don't think we need this anymore. We just need one browser tab. Um, so first you init, then you create window. I think we did it the other way around though. Did we? No, we did init, then create window. So because of all of this SDL garbage that is all of this initialization and all of that. I am not willing to spend my time writing this SDL stuff in my main function because the main function needs to be as small as possible. That's what I think. I think it should be just absolutely tiny. Like it should be some kind of like rendering system in it. Um, Components like just like deserialize or something, 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 and then just run the main loop and that's it. And like it should not be this huge thing initializing SDL inside of main.cpp, but we're gonna do it here for now. But I am eager to actually write the initialization for all of these things. Just make like a constructor that just instead of doing this and then this, gonna do it differently. Also here, um, bitmap surface, load BMP. We don't have a BMP, we have a PNG as far as I understand. So let's see here, SDL load PNG. Oh, SDL image. Okay, it's a funny one. It's like Microsoft Paint level. Oh, it's funny. That's a nice. I don't know. It's just so funny. Okay, let's see. Now that the library is all set up, let's load some PNGs. So this is like a tutorial on SDL. It's pretty good. Um, but the color is terrible. Is it because of the? Wait. Is it because of this? No, has nothing to do. Okay. Why is there a Firefox close and all of that? I thought I disabled it. Is it me messing? Wait, yeah, these were not here. Oh, it's just full screen mode works this way. Okay. It's a bug. I don't need these. What do they even do? They do nothing. This does nothing. These are useless. In i3, these are useless. Don't need them. Anyway, to use any of the image, we need the SDL image header, have to blah 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 blah. Okay, seems to be easy. So I can't see anything really. Also, this is disgusting. What are you doing? What are you doing? What happened? It's terrible, terrible CSS. Okay, SDL init. Okay, blah 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 blah. Create window. If window do that, initialize a PNG loading. Int image flags equals image init PNG. Image init image flags. As the image cannot initialize. Wait, interesting. It's not prefixed with SDL. That's weird. Um, Image flags cannot initialize. SDL image error. 6x equals false. Hmm, weird. Okay. I mean, oh, yeah, that's actually a pretty good way of doing it. Do you set yes, success to true? Okay. Else g screen surface equals get window surface window. Okay, so that's the initialization. What's interesting is that it creates a window, but it doesn't do anything with it. What's up with this? That call to image unit is a bug. Can't the Now that we are Oh, the other day somebody was asking me about this too. Um, and I honestly, I'm not. I don't want to know what. No, I don't want to get into the details of why it is. I actually kind of like people were saying like, well, like I let's not get into that. I'm not sure what this is supposed to be like. Image init. What else could it return? Could it return like zero or something? What is the failure code for this? Does it return just zero? I guess. Okay. If you're to get back, if you were to get back four, back from you, when you said one and two, four and two is zero, which evaluates to false, which is generated, is negated, evaluate true, which is caused by the error code to execute. If you were to get back six, both four and two, when you wanted two, 6 and 2 is 2, which evaluates to true, which is generated negated. Evaluate to false, which is deal to execute. The reason the code is like this is because we only care about the PNG loading bit. If we get that, it means that we can continue. In other cases, this code would be different if we are not dealing with that here. So make sure to brush up on your binary math and stop emailing me telling me that this is. Ah! Oh my goodness. Oh my goodness. Yeah. That's a confusing thing. Okay. So at least I mean he should have just explained what the return like what the actual call means, what it does, and I'm pretty sure all of those like 90% of this would go away, but yeah. Okay, what did he say here? Da, 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 when the nah. Okay, so my image loading function is pretty much the same as before, only now it uses image load as opposed to STL load BMP. Image load can load many different types of format which you can find in STL image documentation, like with blah 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 blah. Okay, so pretty good. Makes sense. Makes sense so far. We need to keep on writing code though. So let's see here. I'm kind of confused that he is making this window, but he's not actually like returning it or anything. It just exists there, and then it gets this pointer gets destroyed. So you get a window, but you can't reference it. So I wonder, um, and he doesn't destroy the window either, as far as I understand. So weird. Hmm. Yes, yes, yes. If you're to get back, nah. Okay. So SDL surface load surface string path. The final optimized image. SDL surface pointer optimized surface equals null. Okay, this one actually returns the surface. Load the image from this. Oh, it is C++. Okay. If loaded equals null, unable to load image. Um, convert surface to screen format. Convert surface. Where does the image get loaded? Oh, okay, so image load. Okay, interesting. Yeah. Get rid of loaded surface. So free surface loaded surface. Convert surface loaded surface. G surface format. What's a G screen surface? Hang on. It's really hard to read this text. It especially because it doesn't have code formatting. Because like if it had code formatting, you could kind of it's gonna be a little bit faster, I think. Um, so I'm actually here. So G screen surface comes from who knows where. I don't know. Where? Highlight all. Is it this? Are these globals or what? Ah, it's these are globals. Oh, what are you doing? Oh, what are you doing? Oh, what are you doing? This is what are you doing? No, don't use oh my goodness me. Okay, maybe it's not a global. Maybe it's like like still. Anyway, that will load the image onto a surface. So, hello, ini, I mean, yeah, SDL just died. Ah, interesting. Did my internet go out? No, I'm still streaming. Am I? Oh, what happened? Oh, so it was like this way. Okay, now it works. It basically quitting full screen fixed it. I don't know. The browser is broken. Okay. Um. All right. I did go out of this. Should be here. Okay. So they tell you create window, bitmap surface equals load BMP, bitmap texture create texture surface, and then free surface bitmap surface. If loop should stop, why do you have a SDL bool? That's weird. It's just probably a type dev bool, SDL bool, but it doesn't make sense. Why would you do this? Renderer. Is it like, yeah, I mean, it could be like for documentation purposes so that you kind of understand, oh, this is to use with SDL, and this is just normal bool, but like, why? This is puzzling. Like, I don't understand the purpose of it, and it's annoying. Like, I want to know why. Okay, let's see here. Create texture from surface, renderer, bitmap, surface, free surface. So kind of starting to understand uh, what should what should be this what the SDL API looks like. And I don't want to stick with the SDL API. I want it to be kind of um, I want it to be kind of library independent. We're gonna see about that. My goodness me, this is annoying. SDL event, SDL quit. Oh, so this is where this is pretty good. This is where we actually implement SDL quit. Although I don't know how they know that it's an SDL quit event. SDL true. Oh my goodness me. Why? Why? I kinda. Okay, I'm gonna Google it later, but I want to know why they use this. I don't know. It's weird. SDL render clear, render copy, render present, destroy texture, destroy render, destroy window, SDL quit. Okay. Um. So I believe the only thing we need to do now is move this one to another screen so I can see the documentation. You can't, but that's fine. And what I'm gonna do is I'm going to actually write the code here. So this is where we actually write the code. So we already have this CR stuff. We have the delay, destroy window. They do all of that down below. But we need to add texture. So let's see here. Creating this window. Then they create a render equals, and this is of type SDL underscore uh, renderer. And we're gonna call here. Actually, it's a pointer. So once we've done that, we are gonna do SDL underscore create renderer. Let's see, window, and in this case, it's just window index. This one is, we're just gonna do -1 or -1, and these are the flags, and these flags are, they say that it should be SDL underscore renderer accelerated. And I like that the language server understands what the parameters can be. That's pretty cool. Not sure how they did it, but that's impressive. I'm pretty sure just a script like that knows what the parameters there should be. But next we need to check if this thing um, failed. So if it failed, which I believe we don't, why don't they check if it failed? Can it be null? I mean, it can be null. Um, so theoretically, we should check if render equals null. In this case, we do what any polite person would do, std cr uh, renderer because get error. Okay, so yeah, this, as you can see, it's a pretty big main function, and I don't like it. I want it to be very small and concise, but that's the beauty of C. I mean, this is pretty much what will happen if you launch this code. Like, this is what will happen. This is the way that things will be executed. I just don't want to write it every single time I create something. So that is going to be fine. I want to know what the flags are for the render. Let's see, software, accelerated, prevent vsync, target texture. Okay. Uh, so it seems like this accelerated one right here is going to be fine. And then once we've done that, we're going to say bitmap Oh, we need to use like this, what is it? Window renderer. Yeah, wait a second. Bitmap surface is SDL sur fa yeah, SDL surface. I misspelled that one, and I'm gonna say SDL surface pointer. And what they call it? They call it bitmap texture equals. What is your problem? It's not top of all. Oh, I did not finish my line. It's not a void. It's not. Don't worry about it. We are going to do SDL. And actually, here we're gonna go to our other tutorial, and we are going to load image load. So that's gonna be image load, and the one that I'm gonna load is going to be assets slash characters dot png. But before we can load this one, we need to assert that, let's see here, int image flags equals image init png, and basically if not image init image flags and image flags, in that case, and it doesn't need this image load. Where does this one come from? It comes from SDL image. You stupid Emacs. SDL image. There we go. And so I don't know. It doesn't know much. Probably the reason why it doesn't know is because it's not within the names. Wait, no, that's probably because they just need to like tell it that we're using SDL, and that will probably work with autocomplete. To be honest, I am not that concerned with it. Okay, so once we misleading indentation statement, oh, okay, it's fine. It's fine, don't have to worry about it. So once we have initted this, if everything is not okay, then you're gonna do CR you're gonna do CErr could not init um, SDL image because SDL get error. Actually, it's not SDL, it's image get error. It's a little different. Pretty good. So next up, and also we forget here to exit one. Should be doing all of that here. But if everything goes to plan, then then we can then load our image here. Once we load it, we need to check uh, if. So because we're following a different tutorial, the way this one structures it is it does this. So load it underscore texture. Oh, actually surface. I mean, doesn't matter. And then if loaded surface, I believe if it's null, um, like, okay, let's make it equal null. In that case, you're gonna do a CErr okay. And if everything goes to plan, which is right here, then, oh, in the else case, well, I mean, the else case is the rest of the program, so we don't have to specify it. We just say, oh, and so we are going to need to return. Oh, sorry, not return. Exit one. There. So inside of here, we will then check um, we need to check. No, we don't need to check anything. We just say SDL convert surface, loaded surface. Here, so the screen I believe is a window. Uh, Format and in 32 flags, we're just going to specify 0 because they tell us to. And that should be the thing, except that the screen surface comes from mm, screen surface comes from SDL get Windows Surface, which we should create um, up here. So we're gonna say window underscore surface equals SDL get Windows Surface from window. And of course, this needs to be SDL surface and should be a pointer. Okay, so with that, should be done. That should be it. And yeah, I guess. Um, let's compile. Oh wait, that's gonna launch it. Let's compile it this way. Undefined reference to image init. Really? Undefined reference to image load. Um, let's go to image SDL image documentation. Hmm, interesting. What can we do? Oh, image init and image quit actually load DLLs. That's interesting. I did not know that. We are looking for undefined reference to image init and image load. I believe the way we change this is by going into our CMake lists. Okay, is it SDL2? How do I link it? Let's see. Instructions, changes. Uh, how do I? see. Hmm. Hmm. Cannot find the thing for SDL image. Oh wait, I can just search SDL underscore. Okay, well then it's not in the main SDL doc. In that case, how do I link it? Because I know I have to link it. I just don't know how to do it. Let's do this way. Which SDL image? Um, yeah, SDL2 image. Oh my goodness. Can you imagine this person pasting basically his entire main file, which is so huge, and just telling, oh, an error is library not found, sdlimage.lib, and like using. Hmm. So it's this way. SDL2 underscore image. The thing I was talking about was this. Look at the size of this file. Look, don't do this, please. And it keeps going. And it keeps going. The only thing that is really important in this entire question is this, like these 4 lines. None of this is relevant. We don't care what you're doing there. We just say, okay, you got a linker error. It has nothing to do with your code. It has to do with the fact that you try to do this, or that say maybe, in this case, he just linked the wrong library. Don't post unrelevant stuff unless you don't know that it's unrelevant. So there they say SDL2 image or this, which we're just gonna do right now. So we link this and we are gonna compile. And as you can see, that compiled just fine. And if I run /build main, we should see our window, which, well, obviously does not exist. In fact, this window is unresponsive in any way. So we're going to need to render something onto it. Okay, we don't need this. So once we have loaded everything, we can then go back here. Let's call SDL free surface onto our loaded surface after we have converted make sure we can compile. Oh, that will launch the thing. This is compile. Okay. Did you mean loaded surface? Yes, I did. Okay. So this is the code that will load our image, create our window. It works, but we now need to abstract it so that we're not just like doing this in our main function, because as you can see, that's quite a lot of code. That oh shit. Just realized that I wasn't actually recording on my screen. Oh my goodness, this happens quite a lot, which is why I should have OBS on the side all the time. I think I need a separate screen for OBS entirely. Okay, that was a joke. Anyway, so, oh my goodness me. Okay, anyway, so this is the actual code. I mean, this happens sometimes to everybody. Let me make sure my stream is still running. I think we're gonna start kind of, like, we're gonna try to get closer to the end of this entire thing. Am I even live? Yeah, seems like I am. Yeah, still going. Um, no comments though. That's fine. That is fine. Okay, so um, this is quite a bit of code, as I said, and because it's quite a bit of code, uh, we just want to have like an abstraction layer over SDL that will just load our texture. Um, so in that case, under I know I have a rendering system somewhere. There it is, rendering.cpp under includes and system. Let's create a file called rendering.hpp. Once we're here, we are going to create a class rendering system. And in fact, we don't have to call it rendering because it's going to be inside of namespace send colon system. Okay, rendering. And this one will be, let's also do a pragma once. Once we're done rendering here, it will not inherit anything, but it will have a few private members. The first private member, according to main.cpp, um, the first one is actually we're not going to write with we're not going to start with the members. We're going to start with the first function, which is going to be the constructor. And this constructor, oh, in fact, instead of, yeah. This is what I want to do. So let's call this abstract class. We're not going to put anything here yet. We're going to have a virtual. I'm not sure if we can have a virtual constructor. No, 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 no. Virtual rendering. Yeah, I'm pretty sure it's going to tell me that you can't have that, and it should be public. Seems you can. Expected semicolon at the end of declaration list. Fix available. C++ requires a type specifier. Well, this is a constructor. Yeah, I guess you can have this, but should be able to have this. Okay, so virtual rendering. Oh, wait, yeah, we need a semicolon here and a closing brace like this. Okay, so rendering. This thing, um, it's basically going to be a system, and each rendering system should expose a virtual, well, in case of the actual system, it will not be virtual, but it's going to be virtual operator, uh, returning void, operator braces, and I don't know. Oh, and it should take ent colon colon registry reference. And it should be, because it's a rendering system, it should be const as well. Although it you may want to modify something, so you should have this, and theoretically, this operator should not modify any internal state of the rendering system, um, but I'm not sure about that. Let's keep it this way for now. Okay, and also this, I did not ask for you. Okay, and the reason why we do this is because now we're going to create a class SDL. Let's do it this way, SDL rendering, which will inherit public rendering. The reason why I'm doing this is because now, uh, here's the cool part. Let's say that we want to swap our rendering system for something else. We can do that because a rendering system should have an initializer. In this case, it doesn't do anything, so we're actually just not going to have it at all. But each rendering system should have this operator with these like braces basically, which takes an ent registry. What that does is it basically tells you, hey, I don't care what you do after you decided which rendering system you did, and after you've done all of your preparation and all of that, just call this operator, and this will actually render things in a loop. When you call this, this would actually display stuff on the screen. And that's really cool because now you have this, what's known in, if you watched the Clean Code Flutter tutorial, which I know nobody did, but there is this idea of a contract where essentially you say that the rendering system must provide this. Okay, and I think there's you can even do it this way, equals 0. I need to brush up on my C++ a little bit. Let's see. Abstract class. Let me do this here. So, oh, can we have dark reader, please? Yeah, okay, better. Pure virtual function is a virtual function in C++ for which we need not to write any function definition and only have it declared. It is declared by assigning 0 to the declaration. Okay. And abstract class is okay. Abstract class can have normal functions and variables along with the pure virtual function. Abstract class can be instantiated, but pointers and references to abstract class can be created. Also, something that I was thinking about was making it static. And, oh, cannot be a static member. Virtual can only appear on non-static members. Oh, that's not very good. Um, okay, it's fine. It's fine. Yeah. Although it's weird, yeah. I mean, I can imagine. Anyway, all right, let it be virtual like this. So now we have this class, which inherits from rendering, and it must implement this operator. So let's do this right now. In fact, let's have a public um, void operator and registry reference override. Oh, you need to specify, I guess. Do we? Okay, I know why it's having issues right now. It's because, mm, yeah. Why is there, wait, this should be public. Mm, oh, so yeah, basically, our LSP is going crazy, saying that we cannot do this because of rendering HPP. Alrighty, guys. Sorry for the interruption. But I think we're gonna end stream now because well, uh, we cannot continue anymore. But this, as you can see, was not very productive, and I kind of hate it because every time I stream, it's like I'm just trying to figure out, and then the next stream, I'm like, oh, there's a solution. I kind of want to get more done on stream, but yeah, I have to finish now. Um, so yeah, have a good day.